All right, we're on to question 4. It says, in how many ways can you draw a hand of 5 cards which has exactly 1 ace? So this one is a little bit of a cool question. That's a really interesting question, but we have to take our time to think about how to solve it. So again, I like to start with this idea of, okay, let's think through what techniques we need to do. Are there multiple events? Are we going to only use sequential counting, or do we need to use combinations? Well, we should spot this keyword of the fact that it's a hand of cards, which really means that it's a group of cards, which means we do need to take advantage of combinations. When I think about what this would have to look like, though, what this hand is going to look like, we want there to be exactly 1 ace. Well, what does that mean that the rest of the cards need to be? Well, basically they need to be not aces. And so, in a way, what we have is just like either the farm question or the team of students question. We need to draw a certain number of cards from different types of cards, different groups of cards. What I need is 1 ace, and then I need 4 non-aces. So then what we need to think about is how many ways to pick each of those things. Well, if I need 1 ace, we'd have to know how many aces are in the deck. You could look that up in your file about decks of cards. But in a deck of cards, there's 4 of each type of card, which means there's 4 aces. Now, how many non-aces does that mean that there are? Well, there are a total of 52 cards, and we just said there's 4 aces, which means that there's 48 non-aces. So then what we're doing is we really need to pick a group. How many of them do I need? Well, I need 4 to make up the rest of my hand of 5 cards, right? The ace together with 4 other cards makes a total of 5. So a group of 4 from, I only want to pick from the non-aces, so from 48. So, and then that one is a combination. So we're going to have a combination from 48, choose 4 of them. And I'm going to have to think about, well, what do we do with these 2 numbers once I figure out what that combination is? Well, remember, it's 2 events, so that would be sequential counting, which sequential counting would say to multiply them together. So that's that sequential counting principle. So let's start to work on this. So I'm going to have 4 times. Let's expand out that combination. So it's going to be 48 factorial divided by 4 factorial, and then 48 minus 4, which is 44 factorial. So I'll just keep the 4 times for now. We'll do it at the very end. Keep working on the combination. So start to write out 48 factorial is 48 times 47 times 46 times 45. And then we hit the 44, which is in the bottom. So put a factorial on it. And then we've got 4 factorial, 44 factorial. So we're going to cancel those 44 factorials out. So then we've got 4 times, in the top of that fraction, we were left with 48 times 47 times 46 times 45. And down here we've got 4 times 3 times 2 times 1 is 4 factorial. So then let's do those multiplications. So let's do 48 times 47 times 46 times 45 is 4,669,920. Let's double check I wrote that right. 4669920. Yep. And then if we do 4 factorial, 4 times 3 times 2 times 1 is 24. So let's do that division. So when we do the division, let's do the 4669920 divided by 24. Gives us 194,580. What did I say? 580. So then that number, that 194,000, that's the number of ways to pick the non-aces. So then we had 4 ways to pick the aces, and then times the number of ways to pick the non-aces. So we're going to have that number times 4 for our final. Remember, we're doing that multiplication because of sequential counting. So then I'm left with 778,320. That's the number of hands with 5 cards where exactly one of those cards is an ace.